Okay, so we're going to look at adding and subtracting rational expressions. Same rules apply as adding and subtracting rationals. When you have a fraction, you have to have common denominators in order to add or subtract. So for my first example here, I have 5/6 minus 3/8. What is my lowest common denominator between 6 and 8? No, not factor, denominator. So that means what do both of them divide into? 48 would work, but even smaller than that is 24. So that means I would have to multiply my 6 by 4 and my 5 by 4, the 8 by 3 and the 3 by 3. So this would become 20 over 24 minus 9 over 24, which is 11 over 24. You check to see if it reduces, and it doesn't, so you're good. So negative 2/3 plus 4/5. What's my lowest common denominator of 3 and 5? Okay, so that means for the first fraction I have to multiply by 5. The second fraction I have to multiply by 3. So I have negative 10 over 15 plus 12 over 15 equals 2 over 15. And again, you can't reduce, so you leave it. What I was telling you before too in the other assignment is make sure you're moving down your page, not across your page. Because then your steps follow a pattern. Because what happens is when you're going across the page, you can make mistakes. And also it's just proper math to go down your page so that your steps are going. And each step has an equal sign in front of it. Okay? So the last one here, I have 7x plus 1 plus 5x minus 2, and they're both over x. So what is my lowest common denominator? It's x. So what do I have to do to these? Nothing. Right. So because they're both over, have a common denominator of x, if you want, you could rewrite this as 7x plus 1 plus 5x minus 2 all over x. 7x and 5x is a 12x. 1 minus 2 is negative 1 all over x. And again, I can't cancel my x with my x here and say that my answer is 12 minus 1, which is 11. Because this 12x minus 1, what I told you the other day, is put a bracket around it if it helps you to remember that that is all one thing altogether. So this one here, because I have a variable in the denominator, I would have a restriction. So what are our steps for adding and subtracting fractions? What's the first thing I did? Right. So I find the lowest common denominator. And once I've done that, then I either added or subtracted my numerators, depending on what the signs are. What do I do to the denominators? You leave them alone, right? You don't add them or you don't subtract them, they stay the same. And then what did I do if necessary? Yeah, reduce if necessary. So when we're looking at rational numbers, same things will apply. You look for a common denominator, the lowest common denominator. You add or subtract your numerators, and then you simplify if you can. So in the first example here, 10y minus 1 over 4y minus 3 minus 8 minus 2y over 4y minus 3. So what is my lowest common denominator? So I don't actually have to change anything. So if I rewrite this, I have 10y minus 1. This 8 minus 2y is being subtracted. So that means that this minus sign in front of here has to affect that 8 and the minus 2y. So this becomes minus 8 plus 2y. So we do that because this is saying minus 8 minus 2y. It's not saying minus 8 minus 2y, like it's not written like this. It's written like this. The brackets just aren't in there, but because it's in front of the fraction, then that means that you need to apply it to all the parts. Yeah. Where do you get 2y minus 3? It's because it's a fraction or a rational number that you need to think about. This one, because this, in this one, we said it was a minus 3, but well, when you changed it. Yeah. Yeah. So then you just collect your terms. 10y plus 2y is 12y. Minus 1 minus 8 is minus 9. 4y minus 3. So if I look on the top there, 12y minus 9, I can reduce. Or I can factor that. I can take a 4 out, or sorry, not a 4, a 3 out of there, and I'm left with 4y minus 3 over 4y minus 3. Because a 3 is a common factor in 12 and 9. Because 12y divided by 3 is 4y, negative 9 divided by 3 is negative 3. It's just a GCF. They can, but before I cancel, I have to do my restriction. On the bottom, 4y minus 3 is not equal to 0, so y can't equal 3/4. So then if I finish, those will cancel, so my answer is just 3. Okay. In example B, and this is what I want you to do to set these up for any of the ones where you have to find a common denominator. And we're not looking at just a number down there, we're looking at variables. So if I look at this, I have xy and x squared, and this is a minus 3, so this is like saying it's over 1, right? Negative 3 is the same as negative 3 over 1. No, you can't, I can't factor anything, and there will be some that you need to factor first. This one you don't. So if I'm looking at my lowest common denominator, this one had an xy, this one had an x squared, so that's like x and x. And then the other one just had a 1, so I don't even need to include that one for right now. No, you can't reduce it first for this one, because then when it comes to doing your common denominator, it's going to affect it. You should, in this case, I would just find your common denominator first. So if you write them like this and you line up the ones that are exactly the same, then that's going to help you to figure out, okay, what do I need to add into this to figure out what my lowest common denominator is? So altogether, I would have 1x, so you go down your row here. Oops. So I have an x times y. That is my lowest common denominator. So if I look at my xy, what is it missing? Another x, right. So what I usually do for that is I just put in a little check mark to say, okay, I need an x there. So this one here, for the xy, I'm going to have to multiply it by an x. So this will become 2x times x over xy times x. Yeah, you have to put whatever you put in the top, you have to put in the bottom. No, you don't have to write it the way I do. I'm just showing it so you can see what I did. So if I look at my x squared one, this one has an x and an x. What is it missing? A y. So that means I'm going to have to take and multiply a y. So this one was missing the y. Because you have to line up the ones that are the same together. So I can't put an x under a y because y and x are not the same. Then if I look at my last one, my minus 3, what is it missing? It's missing x squared and y. So I'll have to go minus 3 times x squared y over x squared y. So now I have x squared y, x squared y, x squared y on the top, or on the bottom. So now you multiply through these ones I had to collect. So I have 2x squared plus 4y minus 3x squared y over my common denominator of x squared y. So if I take a look at this one, what other numbers? Oh, this should, what? They're all here. They're all x squared y, so I can write them all over 1. So then you check and see, can I cancel anything out? Or first, can I factor anything out? So can I take anything out of 2, 4, and negative 3? No, I can't. This one has an x, but this doesn't have an x, so I can't GCF an x. And these two have y's, but this one doesn't, so I can't GCF the y. And there's nothing that will cancel top to bottom. So I'm done. That is my final answer. But I do need to find my lowest common, or not my lowest common, I need to find my restriction. And it really doesn't matter if you find your restriction from here or from where your common denominator was. So my restriction for this one, I have an x squared not equal to 0, and I have, which will just be x not equal to 0, and then y not equal to 0. So those are your restrictions. That is your answer. Okay. So this one says simplify and identify all non-permissible values. So first thing we're going to do is simplify by factoring, if we can, anything in the numerator and anything in the denominator. So if I look on the top here, I have a 4 and a 3. There's nothing I can do with those. Those are going to stay the same. The bottom one here, p squared minus 1. What is that if I factor it? Right. That is a difference of squares. I have a perfect square and a perfect square with a subtract in between, so that's a difference of squared. Of squares, I mean. Second rational, it's just a p plus 1, so I can't do anything with it. So now I set up my lowest common denominator. So my first... No, because these are being added. You can't, they're a denominator, so you can't do that. So my first one, my denominator was a p plus 1 and a p minus 1. My second rational had a p plus 1, so I line those up. So that means my lowest common denominator, if I go down this way, is going to be p plus 1 times p minus 1. So now I go back to my actual rational numbers. So my first one had p plus 1, p minus 1. So is it missing anything from the lowest common denominator? No, so it's good. The second one had a p plus 1. So what is it missing? Right, so it's missing p minus 1. So I need that in there. So this one is going to stay as p plus 1 times p minus 1. This one, for some, yeah, like these ones are simple enough that you can, but there's going to be ones that you have more factors to that you'll need to write them out. So the second one was missing that p minus 1. Yep, because it's no different than if I had 3 over 8 and I was changing it to a common denominator of 16, I'd have to multiply top and bottom by 2. So this one isn't changing, it's going to stay as 4. I can write my common denominator because everything's the same now that I've done that. So on this one, I have a positive 3 times p, so that's going to be plus 3p, and then a positive 3 times negative 1, so minus 3. If this had been a negative in front of here, or a minus sign, then I would have been going minus 3 times p, and then minus 3 times negative 1. So it would have changed my signs. So I have 4 minus 3 is 1, and then I've got nothing to add that 3p to, so it just stays as 1 plus 3p. And my bottom, p plus 1 times p minus 1. What am I going to cross out? Which ones? What am I canceling them out with? Doesn't matter. If they were, you added an extra p in there somewhere. So I can't cancel anything. I can't GCF anything out of that top one. So that is actually done. This is my answer. The only thing I am missing are my restrictions. Usually even in factored form, yeah. So from my denominator, I have p plus 1. So that means p can't equal negative 1. I have p minus 1, so p can't equal a positive 1. I'm sorry you don't like this. No. So the next example, I'm going to just pause there for right now. Because I've got trinomials in the bottom and the top, I'm going to have to factor these first. And then after I've factored them, I'll find my lowest common denominator between the factored form. And then I can do my collecting of terms and then simplifying from there. So tonight what you're going to do is watch the rest of this video and have the notes done. And those questions 13 to 24, you should have those done for tomorrow too. Okay, so the first thing I'm going to do with this one is I'm going to do some factoring. X minus 2 can't factor, but x squared plus x minus 6 is a product and sum. So I'm looking for something times something equals negative 6, and whoops, adds to positive 1. So that's just going to be a 3 and a negative 2. So I have x minus 2 times x plus 3 times x minus 2. So you've probably recognized already that I have a common thing there, x minus 2 times x minus 2. But I'm not canceling them yet. I need to find my common denominator before I can cancel. X squared plus 6x plus 5, so I need something times something equals 5, and we'll add to 6, so that is a 5 and a 1. So x plus 5 times x plus 1. And then the last one will be something times something equals 3 and adds to 4, so that is 3 and 1. So x plus 3 times x plus 1. So this is now where I go to my lowest common denominator. I take and I make my little chart. So this, my first denominator had an x plus 3 and an x minus 2. My second one had an x plus 3 and x plus 1. So I have to put that in its own spot. Whoops, x plus 1. So now when I go to figure out my lowest common denominator, I have an x plus 1, an x plus 3, and an x minus 2. So that means the first one is missing an x plus 1, and the second denominator is missing an x minus 2. So I have x minus 2. This one was missing x plus 1, so times x plus 1. I don't know why I double bracketed that. So that means on the bottom it's going, whoops, I'm going to be running a little short of room here. I'll have to write smaller. X plus 1, and it already had x plus 3 times x plus 2. Sorry, x minus 2. So now my second rational here, minus, I had x plus 5 and x plus 1, and I had x plus 3 times x plus 1. What it was missing was x minus 2, whoops, and x minus 2 on the bottom. Okay, so now what I'm going to do is a little bit of multiplying here. So I have x minus 2 times x plus 1, which is going to give me an x squared minus 2x, if I multiply that, plus an x is a minus x. Okay, actually, I'm going to stop there before I multiply through, because as I look through this, and I could continue with what I was doing, but I'm going to end up multiplying here, having x plus 5 times x plus 1 times x minus 2. So I'm going to end up with a really big number that I'm going to have to try and factor. But if I take a look at this side here has an x plus 2 and x minus 2 and x plus 1. This side here has an x plus 1 times x minus 2. So that is a common factor between the two of those. So if I GCF that out, I'll have x minus 2 times x plus 1. So if I take it out of this side of the equation, that means that I'm left with 1. And on this side of the equation, if I GCF x plus 2, x plus 1, and x minus 2, I'm left with 1 minus x plus 5. And I still have my common denominator here of x plus 3 times x minus 2 times x plus 1. So if I take a look at this now, I'm going to come back and do my restriction in a minute, but I'm going to take a look at what I can do from here. So on here, because these are all being multiplied together, so this is a factor, x minus 2 is a factor, x plus 1 is a factor, and this 1 minus x plus 5 is a factor. So because they are factors, I can cancel. I can't cancel parts of the factor, but the whole thing. So my x minus 2 and my x minus 2 will cancel, and my x plus 1 and my x plus 1 will cancel. So what I'm left with then is 1 minus x times negative 5, so 1 minus x minus 5 all over x plus 3, which is negative x minus 4 all over x plus 3. So that is my final simplified answer. That is the simplest way of doing it instead of multiplying it through like I was going to do. I still need to do my restriction. So for my restriction, I need to go back to my lowest common denominator. So I have x plus 3 not equal to 0. So x is not equal to negative 3. I had x minus 2 not equal to 0. So x is not equal to 2. And x plus 1 is not equal to 0. So x is not equal to negative 1. So those are my restrictions. And at this point, after doing restrictions for this is the third section, you could go, instead of writing these parts down, you could go straight to just telling me my restrictions are x not equal to negative 3, 2, and negative 1. Okay, the last example says simplify and identify all non-permissible values. So I have 2 minus 4y divided by y minus 4 over y. So it says get a common denominator in both the numerator and the denominator of the complex fraction. So if I look at this, I need to find a LCM for the top, a lowest common denominator for the top, and lowest common denominator for the bottom. So if I take a look at this one for the top, I have a 2 over 1, and I have a negative 4 over y. So that means my LCM is going to be or lowest common denominator is going to be a y. My top one had a 1, and the bottom one had a y, so that means I have a 1 times y, or just y. So that means that this one on the numerator, I'm going to have to multiply by y over y, and this would be minus 4, and that already has a y in it, so there's nothing I can do there. All over, and make the bar in between larger. So the bottom one has the same thing. This is a y over 1, and I have a negative 4 over y. So my lowest common denominator, again, is a y. So that means that I'm going to have a y times y over y minus 4 over y. So here I have 2y minus 4 divided by y all over y squared minus 4 over y. So if I think about this, this bar is the same as a divide sign. So I can just write it as 2y minus 4 all over y divided by y squared minus 4 over y. Okay, if I divide by fractions, I need to flip and multiply by the reciprocal. But before I do that, I have a 2y minus 4, so I'm going to GCF at 2 to have 2 times y minus 2 over y times y over y squared minus 4 is y minus 2 times y plus 2. Okay, and because this is a multiply in here, I don't have to worry about finding a lowest common denominator. I can just cancel wherever I can. So my y and my y will cancel. My y minus 2 and my y minus 2 will cancel. And then I'm done. I can't cancel this 2 with this y plus 2 because this has a y being added to it. So my final answer on the top is a 2. And on the bottom I have y plus 2. My restrictions then, I go back to, before my flip I had a y and a y, so I know that I have y not equal to 0. And then once I did the flip I had a y minus 2, so that means I can't equal 2, a y plus 2 means I can't equal negative 2. So if you wanted to, you could just rewrite this as y is not equal to 0 plus or minus, or plus or minus 2. Either way is okay. So you need to make sure you have these notes copied down into your booklet for tomorrow, and then tomorrow in class we'll work on these questions.